So that little exercise in the last video showed us that we can inquire into the way that our own knowledge is organized just by asking certain well-aimed questions. So in this sense, the representation of knowledge has been a theme throughout the 20th century in philosophy. And it unpacks into many different kinds of questions. So here are some things I can claim I know. I know the capital of Ireland is Dublin. And I know how to tie my own shoelaces. They don't give you a PhD for nothing. And I can find my way from my bedroom to the kitchen in the dark. Now, let's think about where the knowledge is. Well, the knowledge that the capital of Ireland is Dublin goes around with me. The knowledge of how to tie my shoelaces is really only there when shoelaces are there too. And certainly the knowledge of getting from my bedroom to the kitchen in the dark seems to require me to actually be in the dark in my house. So there's different kinds of knowledge, and one way of beginning to unpack this that's proved useful is to distinguish between knowing that and knowing how. So I know that the capital of Ireland is Dublin. I know how to tie my shoelaces and how to navigate my house. So that's a useful kind of distinction. Let's look at that one. The capital of Ireland is Dublin. This is explicit. It's the kind of stuff you can put into a sentence. And it's disconnected from context. You can take me and put me on a desert island and ask me, what's the capital of Ireland? And I'll probably respond, Dublin. So there must be something about my brain, body, and history that allows me to state this fact. So we can refer to that as that I must somehow represent this knowledge. And we have vast amounts of potentially explicit knowledge. It's often called propositional knowledge because it can be expressed in sentences which are true or false. Those things we think of as propositions, which we've met a few times now. It would be a grave mistake to think that most of what you know is known in this form, or that knowledge is simply the accumulation of facts which can be enumerated. When I was a kid, you could get books for Christmas that were called the Boy's Book of Facts, Boy's Book of 10,000 Facts. They were exciting, but they weren't exhaustive exactly. But explicit propositional knowledge has been studied much more than the other kind and knowing how to do things. And so we can infer some things about the manner in which that knowledge is organized by looking at the kind of questions that are easy or hard to answer. And one domain in which this has happened is the domain of artificial intelligence. Now, I note at the bottom of the slide that the meaning of that term has changed greatly in the last few years. And when it arises in the context of this module, I typically mean artificial intelligence in the sense in which it was meant in the 1970s, not in the sense in which it's meant in 2020 or 2021. AI systems were originally thought of as systems with a great deal of propositional knowledge stored in databases of some kind. And so the manner in which that knowledge was stored became itself a research topic. Databases themselves need to be organized and structured. So, for example, if we were trying to represent the knowledge I have that I can put into sentences about cats and dogs, I'm capable of saying things I know about cats. I know that cats have fur. A cat is an animal. A cat chases mice. A cat, there's a lot of things I could say about cats. And there's a lot of things I could say about dogs too. I'm a cat person, not a dog person. You may differ. And you know what? They overlap a lot because cats and dogs are quite like each other in a way that a cat is not like a galaxy, for example, or an ice cream. So they're pets, they're animals, they have tails, they like to be petted. And so if I was to create a database that stored all this knowledge explicitly, it seems very inefficient to store it as all these individual sentences. So early work in artificial intelligence, which was understanding knowledge to be stored in this symbolic propositional form, came up with various ways of reducing the size of those databases. The semantic network shown here, a very simple example, shows you how some of the knowledge on the previous slide could be encoded that avoids some of the redundancy there. So all mammals are animals, for example. So if a cat is a mammal and a dog is a mammal, I don't need to store separately the statement that a cat is an animal and a dog is an animal, because if I have cat is mammal, dog is mammal, and mammal is animal, then by inference I have cat is animal. Notice that the way that you structure your semantic network here will influence the amount of time it takes you to answer queries. So to answer the question, is a cat an animal? If everything is stored explicitly, I have to find the right single statement. Here I have to follow two paths through the network. And you can imagine this as being much, much larger, where the length of the path that has to be followed to answer a query will influence how quickly that question can be answered. Recall our debate about the phone numbers and the names. So this was a form of encoding of propositional knowledge from early AI, and it's based on this basic insight that the way in which such explicit knowledge is structured and organized influences what you can do with it and how accessible various ways, various elements in there are. Another thing to note, of course, is that if you were to go down this route, any such propositional knowledge depends upon our understanding of the world, things in the world, as being divided into categories. So this started off with the assumption that we could distinguish cats from dogs. Now there's been an awful lot of work done on categories, and this feeds in then to these considerations of how explicit knowledge might be stored. So we'll move on to some thoughts about categories in the next video.